Welcome to Statistics Simplified for Beginners, brought to you by Martin Tutorials. I will be teaching statistics for absolute beginners. You've heard the term statistics, you don't know what it's about. And believe it or not, there'll be very little actual mathematics in this lecture because I'm talking about it. I might say to you, in this situation, they do the mathematics to calculate that, but we won't be doing much calculations in this lesson. As I said, it's for people who've never learned about statistics before. And you might see me looking to the side sometimes. I'm not denying the fact that I have notes prepared for today's lecture, and every so often I have to have a quick look at them. Okay, so I'm going to explain to you what it's about. Let's pretend you and I work for the municipality of a city, and the city has exactly 1 million people. I chose 1 million because it's an easy number. You don't want us to work with 249,000 ... Let's pretend it's 1 million people. Our job is to work out how many schools, how many hospitals, how many this, how many of that facility, etc. is needed based on the population and the ages. And you give me the task of going out and finding out how many people of each age in this city. And I say, sure, I'm going to do all the work. I'll go out and I'll come back to you. I say, I have good news for you. I have all the information you want. Here's a list, a big list of 1 million names and their ages. Number one is Willie Make It. Willie Make It is 13. Number two is Betty Won't. Betty Won't is 54. Number three, so-and-so. Number four, so-and-so. All the way up to number 999,999. That's Will Yago, who is 55. And number 1 million is Grace Philly, who is 83. There's 1 million names, and there's their ages. And you look at this list, 1 million names and 1 million ages. Where do I start? What do I do with it? That's not too much help. But if I came to you and said, based on this list of 1 million names and ages, we realized and calculated that there's going to be 10,000 more students requiring elementary schools compared to before. Based on this list, there'll be 8,000 people needing secondary schools. Based on this list, there'll be so many more hospitals needed. We notice a trend in this particular illness at the rate it's been increasing in other years. There'll be so many more people. And there looks like at the moment we have so many retirement homes. There'll be this number of people requiring retirement homes starting next year, and therefore we should build so many more, etc. That's a lot more useful than me simply giving you, here's 1 million names and their ages. And that's what statistics is about. It's about converting information into a useful form. It's converting it. See that list of 1 million names? I converted it into a useful form when I told us we need so many schools and so many that's what statistics is about. And of course, how you convert is depending on your needs. A whole bunch of students writing a test, and it's to get into various other exams or places. If they say to us, we need the top 20 percentile, we need to know what mark you need to be in that top 20% of the students. If they say to us, we only accept if you get 80% or more, then we need to know who gets 80% or more. And here's something else that's interesting. Maybe the average interests us. This test is meant to be standardized, and you should get the same results each time. So we can take the average of this test to compare it to the average previous years. We want it to be the same. If it's not the same, we need to investigate why. The actual mathematics word is mean. Mean is the statistics word for the average. And here's another interesting issue. let's say some people write another exam, and in this particular exam, what interests us is not just the average, but the variance, or how much they vary from the average. Let's say this year the students got 75%, and the previous year they also got 75%, except the year before, this, if we had the list of students, one got 70, one got 80, one got 72, it's all very close to 75. This year, this student got 40, that student got 100, etc. Even though it's the same average, the variance from the average is different. That concerns us because the nature of this particular test, the students meant to work as a team and study together, and we expect them to get about the same mark. And even if the average is the same, it concerns us that it varies so much. And I'll give you one more example. Let's say we're scientists working with elephants, all right? And we are studying the male African elephant. And we know as a fact the average weight of a male African elephant is 12,000 pounds. We've worked with them many years. We've had lots and lots of evidence to show the average is 12,000 pounds. And now we're working with this particular elephant right here. I could not find an elephant to fit in the studios, so we'll have to pretend there's one. And even if I did have an elephant here, I don't know if that elephant will behave for us. Anyway, this particular elephant is 13,000 pounds. And remember, we said the average is 12,000. So if this elephant is 13,000 pounds, does that mean he's slightly heavier than the average, much heavier than the average, overwhelmingly more heavier than the average? For that, we need to find out the variance of their weights. And what I mean is, if the average is 12,000, let's say most elephants are between 11,500 and 12,500. The overwhelming majority are in that range. Then 13,000 is much heavier than most of the elephants. He'd be considered very, very heavy. If with that average of 12,000, most elephants are between 9,000 and 15,000, then 13,000 would be slightly more than the average. That's why we need to know how much they vary. And one way of calculating variance is what percentage are big or smaller. Because if I say a lot heavier or a little bit heavier, that could be subjective. But if I say to you, based on information, this elephant is heavier than 80% and lighter than 20%, that's a way of showing how much heavier. And that's where statistics come in. We have charts with lists of elephants and their weights. There's a way to mathematically calculate, and that I'll give in another lesson on my Martin Tutorials YouTube. But there we use the mathematics to work out if this 13,000 is how much heavier or what percentage is lighter or heavier than this elephant. Okay, and what's beautiful with statistics is that it's used in so many fields, like in business, calculating customer behavior based on past information, how often we're going to get more customers, etc. And or even in medicine, clinical trials, testing out a new type of therapy. If it is helpful, we find a way that removes any bias and see if people are benefiting or not. Or in law and order, how often crimes take place, how often accidents might happen based on previous information. And one interesting way of using statistics is a scatter plot. Let's pretend again, I'm just making up in medicine, and someone said there's a certain illness and there's different levels of this illness. You can be slightly sick, very sick, extremely sick. And someone said there might be a relationship between this illness, how severe you have it, and frequency of watching television. And we take lots of patients at random, and we work out how severe they have their sickness, and we plot it on a chart. And okay, it's called a scatter plot. Let's say we have numbers. Along here we put these numbers represent, I haven't written anything in, I'm making up a usage of this plot. Here's numbers representing how severe you have the illness. There's numbers here regarding how many hours per week you watch television, and each dot relates to a patient. So if this patient has this severity of the illness, watches television this amount per week, we put a dot. And based on this chart, if this was true, there's a negative relationship. The more you have the illness, the less you watch television. There's a few exceptions, like this person has a very mild form of the television and very little television, but in general, the more severe the illness, the less you watch television. That's one example. And I'm just making up examples, I'm not saying it's true, I'm saying if this was the case, based on this scatter plot, I don't see any relationship. It's not more or less, will it be more or less of the other? And here's another example. And here there's clearly a positive relationship. The more severe the illness, the more likely you have that illness. And of course, that's why scatter plot you visually check. There are sometimes exceptions like this one or that one, but in general, the more of one, the more of the other. What a scatter plot does not tell us, it tells us a relationship, but does not tell us if which causes which. So if I just, for example, it's what I used a minute ago, how severe the illness and how often you watch television, it does not tell us if having this illness makes you watch television more, or watching television more gives you this illness. This plot does not tell us which causes which. It tells us the more of one shows the more of the other, and we'd have to do other research maybe to find out which causes which. There's even a third possibility that neither causes the other, which doesn't make sense because it's relationship. There could be a third variable. It's maybe eating a certain food. The more you eat this food, the more you're going to get this illness, and the more you're going to watch television. And these people eat that food a lot, and therefore have a severe form of this illness and watch television a lot. So it's a third variable that makes both of these increase. So that's another possibility. And this plot tells us a relationship, but doesn't tell us which causes which. And someone once put it nicely that statistics is about numbers telling a story, using numbers or a plot to explain what's happening. And basically, it's converting numbers into a form that makes us understand what's going on, or what's needed, or relationships, etc. I hope you enjoy this introduction. I want you to please rate today's lecture on a scale from 1 to 5. 1 is terrible and 5 is outstanding. If you rate this a 1, please click subscribe. 2, click subscribe. 3, click subscribe. 4, please click subscribe. And if you give me a 5, please click subscribe if you haven't done it already. How's that for being optimistic? With this type of reasoning that I want you to vote for me no matter what, I should go into politics. Anyway, I hope you enjoyed this introduction. I hope it was useful, and talk to you all soon on Martin Tutorials.